One of the most important products of science is the peer-reviewed scientific article. This is the instrument that allows science to be shared among scientists and with the public. Because science is kind of a universal language, with everybody sharing the same basic assumptions and style, knowledge can be shared easily and each new inquiry can be built on the foundation of previous knowledge. This module will be dedicated to how health science is reported, so you will be armed with the necessary basics for entering into this scientific conversation. The basic structure of the scientific article in almost any field of science includes these sections: the abstract, introduction, methods, results, and discussion. These sections may seem pretty self-explanatory, and for many students, writing the scientific paper can seem like a simple process of plugging information into these sections. But often, even scientists forget that the whole point for the article is to tell a story that is meaningful, that has stakes for health science and real people. Remember how a good research question should be scientifically and socially relevant? Well, so should a scientific article. With this in mind, let's see what each section is for and what it should convey to the reader in order to help you tell the story. The abstract is the first impression and the snapshot of the whole study. This is a brief paragraph that summarizes everything important about the study, the rationale, methods, and the main findings and conclusions. Don't be coy with your abstract. This is not a story whose ending you want to keep secret. You should clearly and succinctly tell the reader exactly why you conducted the study, what you did, and what you found, using the main keywords so readers can search for your article in databases. Keywords should include things like the main independent and dependent variables, the population you're studying, if that's special or important, any special methods used, or theoretical problems addressed. The abstract exists so that readers can skim it quickly and decide if this article is relevant to their own research and whether they want to read the whole thing. The introduction is the part of the conversation where you set the scene. When you're telling a joke, you can't go straight to the punchline, right? You have to convey the information that sets the foundation first. Here is where you must answer the question, why did you do this study? And what basics do I need to know before I read further? If this is not communicated well, there's no motivation for people to read on. If the reader is left with a shrug and a "so what," then the introduction has not done its job. An intro doing its job includes laying down the rationale for the study. For example, teen suicide rates have been increasing in recent years, so prevention methods are very much needed. Also, the essential background information, for example, previous studies have mostly examined the effectiveness of suicide prevention methods aimed at teens in general, but few have examined prevention aimed at teens most at risk for suicide. And lastly, you must explicitly state the objectives. For example, the objective of the study is to test the efficacy of a school-based one-on-one intervention aimed specifically at high-risk teens. Again, this is not the same as writing a mystery novel. We don't want to keep the audience hanging or wondering. We want to tell them in no unclear terms what the study is about. The methods is no less important in communicating the point of the study. Having a good rationale is a really good start, but explaining how the study objectives were achieved in step-by-step detail is the part that lends credibility to a scientific article. After all, whether your findings are trustworthy depend entirely on how you went about finding them. The key points to cover in the methods section include 1. The study design. This refers to the general approach overviewed in Module 4. Is it a cohort study, an experiment, a cross-sectional survey? Be explicit about this. The population and sample. Describe specifically the target population you're trying to study and how you went about finding a sample to represent them. What were the inclusion and exclusion criteria? Where did you go to recruit potential participants? who did they end up being in terms of their age range, gender breakdown, racial, ethnic breakdown, socioeconomic levels. Tell us about those factors. Define key variables. Often, this is already done in the introduction, but it doesn't hurt in the methods to make sure it's 100% clear what variables you are studying. For example, perhaps you are looking at childhood lead exposure as your exposure and independent variable. What is your outcome and dependent variable of interest? Cognitive functioning? Cardiac health? Operationalize your variables. What aspect of cardiac health, for example? Once you have your variables defined, you must also specify the measures you will use to quantify these variables. If you're measuring cardiac health, will you measure blood pressure? Will you measure heartbeats per minute after exercise? Will you look at the participant's medical record and count the presence or absence of cardiac diseases? In the procedure section, which comes next, you will tell the step-by-step story of how you went about collecting data. This section should read like the past tense of a manual, such that any competent researcher who reads this section should be able to replicate your study exactly the way you did it, without having to call you to ask major questions. The last part in most method sections describes the statistical methods used for analyzing data. This includes the statistical tests used, and what specific research question or hypotheses they addressed, and any software used to perform these tests. Depending on the type of study, you may also need to report other key items in the methods section. For example, if your study tests a new intervention for a disease, you need to describe in detail what the intervention is. If it's a correlational study, you should describe the database from which you pulled your data. If there are any specialized laboratory procedures or any special instructions you gave to participants, all of these should also be described. I often find that by the time I, and other scientists, get to writing the results section, we've been thinking about the study for so long that every detail of it feels like common knowledge. For the audience, this is most likely not the case. The results section is not an opportunity to show off or demonstrate how complicated your analyses were. The goal is to make it as straightforward and easy to understand as possible. You do need to present the detailed statistical findings, but you should also present it alongside quick reminders of what hypotheses they were meant to address and what the findings mean. For example, instead of merely saying, the odds ratio was 3.0, which was statistically significant, p less than 0.05, which may leave readers wondering, wait, what were the different groups again? Or what odds ratio of what again? Or even, what does an odds ratio mean? You could say instead, to test the hypothesis that high lead exposure group was more likely than the low lead exposure group to develop symptoms of dementia, an odds ratio test compared rates of dementia in these two groups. Results were consistent with the hypothesis, showing a threefold risk of dementia in the high exposure group compared to the low exposure group. Odds ratio equals 3.0, p less than 0.05. However, the results section should be free of too much interpreting. We can say that the findings are consistent with the hypothesis, but shouldn't go further to say that, therefore, lead poisoning is a major problem in society that should be a high public health priority. Although this statement is likely valid, it is still an opinion or interpretation, not a fact that is strictly based on the data from this study. Don't worry, you will be able to make those statements in the discussion section. But while we're still on results, it's worth talking about tables and figures, which are not just pretty parts of a scientific article, but important tools for your story's success, or rather your article's success. Often, even scientists are overwhelmed by a lot of statistics presented in text format. I confess that I personally get bored and lazy when I have to wade through a ton of information in the results, or I simply forget what I read earlier by the time I get to the end of it. In those times, I often ask, Hey, can you show me the results in a more visual way? For example, remember the correlational study we read about, where they're talking about the relationship between political orientation of a country and its citizens' health? This table in the study helps us see at a glance what they mean by political freedom and how they measured it. It's much easier than wading through points in that's stuck into the middle of long paragraphs that's really dense. And so if I want a quick reminder of what they meant by freedom, I would have to go through all of that text all over again. In this way, I can see at a glance exactly the information that I need. Later, when presenting results, they showed us in graphic format comparisons of maternal mortality rates between different types of political climates. We can see at a glance that the dark orange bars, representing the free countries, have a lower maternal mortality rate than partially free and not free countries, represented by white and light orange bars. This is at least the pattern for low-income and middle-income populations. See how it's much easier to wrap our heads around when we can see these results represented visually than if we had to read every single statistic and in word and number format in the middle of paragraphs. The discussion, as much as the introduction, is where you do most of the thinking in your article. Ultimately, this section answers the question of, so what? Now that you've done the study and you've reported your findings, what does it all mean in the grand scheme of things, and how does it help society and science? So for this section, you will want to start with a brief summary of the key findings. You don't have to repeat the statistical details here, just use plain language. Then talk about the limitations of the study. Don't worry that this will make your study look weak. Every single study has limitations, and it actually adds to your credibility to acknowledge the limitations when interpreting your findings, rather than to ignore or miss them. For example, perhaps your sample was quite small. That's okay. You can acknowledge this and then add that further investigations should try to recruit a bigger and more representative sample. And this doesn't mean your study is useless. It means that it is a preliminary step that paves way for bigger and more expensive studies in the future. And these preliminary studies are very much important. Then you can let your hair down and begin to interpret the results. Here is where you put your findings in the context of previous findings, perhaps coming to the conclusion that, say, lead contamination in groundwater is very troubling, especially now that we know it increases risk for dementia too. Be careful to be on the conservative side of interpreting your findings. Almost never do scientists use the words prove and certainly and any other extremes, because there is always room for error in scientific studies. If you use those words and become very, very enthusiastic about your findings, then you start to sound like an infomercial, and that is not how scientists want to sound. If you want to be taken seriously by other scientists, you will stay well within the bounds of what your data actually showed you. Lastly, answer the question that drives all of health science research. So what? How are the findings scientifically and socially relevant? What sweeping conclusions can you draw or not draw? What future research is needed to better answer these questions? What theories have been furthered or hindered by your findings? To review and sum up, the goal of the scientific article is to tell the story of the scientific study you undertook. Lead with the abstract, which is the elevator pitch for the whole study. Then comes the intro, which sets the scene for what the state of the world was like before your study and why you did it in the first place. The methods can then explain the details of what you actually did, in enough detail that somebody else can read it like a recipe and recreate the exact same study. The results should then read like a diagnosis, a dispassionate, point-by-point report of what you found, sticking strictly to the facts, but presenting them in a way that is easy for others to understand. Lastly, the discussion is like the spirited conversation at the bar, where you can lay out your interpretations of the findings. You can concede any limitations and argue for why the study is nevertheless interesting and relevant. Here's where you zoom out and talk about what the study means in the bigger picture. One great piece of advice I've gotten for presenting scientific findings, whether in a written article or in an oral presentation, is this. The point isn't to demonstrate how smart you are, but to make the audience feel smart. With this in mind, you will write with the story in mind and contribute meaningfully to the scientific conversation.